Let us next see rules for arithmetic operations involving significant figures. We have already seen that when we measure a physical quantity using some kind of device, we are bound to make errors because the device has its own limitations. So our measurement can only be approximate. That is the best we can do. It will never be exact. And we also have seen how we can use significant figures to indicate how precise the measuring device is. And to not lose these significant figures when we change from one unit to another, we have seen that we should ideally use the scientific notation. While all these things are very good, but if we go one step further and use these approximate measurements to next do calculations, what will happen? Let's see. Suppose you have an object and that object's mass and volume was measured using some devices and these values were obtained. The first one, the mass value is 4.237 gram. So there are four significant figures, 4, 2, 3 and 7. 7 is the uncertain digit, we already know these things. And the volume is 2.51 cubic centimeter. So here there are only three significant figures, 2, 5 and 1. Alright. Now if we use these values to calculate the density of the material by dividing mass by volume, say we just simply divide this number by this number and we get this number, this much gram per cubic centimeter. The question is this, should we really keep this many digits? If not, why not? And then how many digits should we keep? Why should we not keep these digits? You see, these digits are not, of course, everything here is coming indirectly from these two measurements, which themselves are approximate only. So these digits are not directly coming from any measuring device. They are not, strictly speaking, physical, but they are a result of physics and mathematics. That is why it does not make sense to keep this many digits, because this many digits do not really indicate how precise this measurement is or this measurement is. And their own precisions are indicated by how many significant figures there are. But if you keep this many digits, that information is lost. So then how many digits should we keep? What should be the rule for division or say multiplication or addition or subtraction of physical quantities or measurements which by their very nature are approximate? Let's see, there are some rules. Okay, so this is the rule for multiplication or multiplication and division actually. So let's see what this rule says. In multiplication or division, the final result should keep as many significant figures as there are in the original number with least significant figures, with the least number of significant figures. For example, here you have these two numbers and they have been used to calculate that one. This one has 4 and this one has 3 significant figures. So here also we should keep only 3, the least number of significant figures, because that is how accurate this measurement is. So we uniformize the two things and choose the least, and that's why. Okay, so this should be D, because here there are 3 significant figures, here also there should be 3. The original one was 1.688 something, so we are cutting that number there. At this digit we are cutting it. So to account for that 8, instead of keeping 8 here, we write 9. You already know this rule at least. Similarly, if you look at an example that involves multiplication of two such approximate quantities, measured quantities, then you can consider, for example, the speed of light, which is 3.00 times 10 to the power 8 meter per second. So this 0.00, it indicates that in this measurement there are three significant figures, 3, 0 and 0. Whereas if you see the number of seconds that 1 year has, then this value can be seen. I mean, say someone measured this with some kind of device and this was found. So here the number of significant figures is more, 5, 1, 2, 3, 4, 5, 3.1557 times 10 to the power 7 second. So if you now multiply these two things to know the length of light year, that is the how much distance one light year is, then this is how you should write the result of that multiplication, because we have only three significant figures here. So here also you have to choose three significant figures, and 10 to the power 8 and 10 to the power 7 of course get multiplied separately and give you 10 to the power 50. So that is the rule for multiplying approximate quantities with significant figures, multiplying and dividing. For addition and subtraction, the rule is slightly different. Here we are not looking at significant figures but decimal places. How many decimal places the numbers have. And the rule here is this. It reads, in addition and subtraction, the final result should keep as many decimal places as there are in the number with the least decimal places. If this rule is not followed, say, and someone adds these three mass values, which are all measured, so all of them are approximate, so 436.32 gram plus 227.2 gram plus 0.301 gram, simple-minded addition, mathematical addition, then one gets this figure. Okay, so how many decimal places? The first one has 1, 2. The second one has only one decimal place. The third one, however, has, although this number is very small, but it has 3 decimal places. So the final result should not be like this, because the number with least decimal places is this number. So that many decimal digits only we have to use. So we will just simply not consider this other two. We will simply write 663.8 gram. Okay, so these rules have to be maintained when calculating, when operating these approximate numbers using the usual arithmetic operations. For subtraction also it is similar. So these are the rules. After this there are some other things also. For example, how to round off some digit, where say you will not, you have to consider only some digits in whatever your calculation is, right? According to these rules, how can you round off the digits? What will you do if the digit is, say, greater than 5? You see, this is what I said then, that you already know these rules a little. If it is greater than 5 and that's where you are cutting the number, then you add a 1. Otherwise you don't add, but there are some other things also that we will discuss in the next video. And then there are some examples, and after these things are over, we will go to dimensions of physical quantities. Physical quantities come with dimensions. Not all of them, most of them have dimensions. Some are, however, dimensionless. What are these dimensions? Of what use they are? So we are going to see these things next. So anyway, that's just all. So see you tomorrow with a new upload. Until then, this is me, Lucifer, from a mathematical group. Have a nice day.